And question number 3, again, this is not written in a standard form as homogeneous or inhomogeneous recurrence relation. So we need to find a way to transform it into standard form. By looking at this recurrence relation, probably first of all we have to think about how to get rid of the square root. To get rid of the square root, this an in fact can be rewritten as an minus 2 over an minus 1 raised to power 1 over 2. Since we have power and then we have divisions, maybe what comes in our mind is, what if we apply log on both sides? If we apply log on both sides, so this power will be multiplied by the log and the division will be transformed into subtraction. So take log, and here I'm going to use log 2. Why log 2? We will say later, because if you want to find the constants, these are all like we have power of 2 in the constant, so it will not create too much constants. However, you can use any log, even you can use len if you wish. So log 2 both sides, take log 2 both sides. So we will end up with log of 2 an is equal to log 2 of an minus 2 over an minus 1 raised to power 1 over 2. This will lead us to the next simplified equation. Log 2 an is equal to 1 over 2 log 2 of an minus 2 minus log 2 of an minus 1. If you remember the rule for log, if we have division, then it will be distributed and transformed into minus. Multiplying this equation by 2, so we will have 2 log 2 an is equal to log 2 an minus 2 minus log 2 an minus 1. Now we have 3 terms of this equation. This is the first term, this is the second term, and this is the third term. In all of these terms, we have log 2. So maybe we can think about the following transformation. We can say let bn is equal to log 2 of an. So now ask yourself, what is bn minus 1? It will be log 2 an minus 1, which is this one. What is bn minus 2? It is log 2 an minus 2, which is this one. So substitute. We will get 2 bn equal to bn minus 2 minus bn minus 1. You rearrange the recurrence relation as before. You put the largest subscript first, then comes next minus 1, you take it to the other side, minus next, which is bn minus 2. Okay, you take it also to the other side. By the characteristic polynomial, it will be 2x squared plus x minus 1 equal to 0, and this will be equal to 2x minus 1 times x plus 1 is equal to 0. Then we have the first root is 1. The second root, I think here I have 2. In here, we should have 2. So R1 is not in fact 1. So R1 will be equal 1 over 2. And R2 is equal to minus 1. So the general solution, solution of Bn, not An, equal to, you substitute, or you find the first one will be a half raised to power n plus C2 minus 1 raised to power n. Now we need to find the constants. Okay, finding the constants. But we need to find the constants of the new recurrence relation. What was given in the beginning? What was given in the beginning that A0 was equal to 8. And now we need to transform it. If you remember that B0 should be equal to log of 2A0 because of the transformed equation. Look at the transformed equation here. That Bn is equal to log 2an. So A0 is given. So this will be log 2 of 8. And you know that 8 is 2 to the power 3. So the answer is 3. So notice that we are having integer here. If you are using other than log 2, then you are going to have fraction. Now for A1, it was given as 1 over 2 the square root of 2. And this is in fact is equal to 2 of minus 3 over 2. Why? Because this 2 is 2 to the power minus 1. And this 2 is raised to power minus half. Minus 1 minus half will be minus 3 over 2. So if you take the take it out, up, it will be minus. So this is 2 raised to power 1, 2 raised to power half. The addition of the powers will be 3 over 2. You take it up will be minus 3 over 2. From here, we need to find B1. So B1 will be log 2 of A1, which is log 2 of 2 raised to power 3 over 2. And the answer will be minus 3 over 2. We need to now substitute into the equation to find these constants. So we have B0 is equal to 3. So what the equation that we will have C1 plus C2 is equal to 3. And for B1 is equal to minus 3 over 2, we will get 1 over 2 C1 minus C2 is equal to minus 3 over 2. And this is equation number 2. Using the calculator, so solving for the constants, we will have C1 is equal to, we will have C1 is equal to 1 and C2 is equal to 2. So we will have Bn is equal to 1 over 2 raised to power n plus 2 times minus 1 raised to power n. But this is the answer in terms of Bn. Now we need to find the answer in terms of An. Okay, so what is the relationship between, we need to find An, not Bn. So what's the relationship between Bn and An? Since Bn is equal to log 2 of An. So now how to take An outside log? To take An outside log, and this is base 2. So you have to raise this side by power of 2 and you raise this one by power of 2. So from here we will have 2 to the power Bn is equal to the power log 2 An. Now you know there is a rule if log is in the power, so you can swap, and when you swap you will end up with the power log 2 and 2. So we will have An is equal to raised to power Bn, and remember and Bn is already found, so this will be, okay, we can say that An is equal to raised to power to this equation. And this equation is equal to 1 over 2n plus 2 minus 1 raised to power n, and this is the final solution.